Hello, and today we're at the Kempton Steam Museum in southwest London. My name's David Walker, and I'm going to show you the mercury arc rectifiers we have here that drives our 1920s machinery. In the early part of the 20th century, electricity supplies were not generally available. What there was usually generated by small companies, mostly for their own need, and then distributed in the immediate local area. As a result, there was no standardization of the type of electricity or the voltage. Companies generally chose to generate whatever was convenient for their own needs. That might be DC, it might be AC, it could be high voltage or medium voltage. And if it was AC, it could be at any frequency that the machinery they used generated. On this site, it was convenient to generate DC voltage because what they wanted it for was to power motors and lights, and DC at that time was much easier when it came to motors, and so they chose to generate 200 volts DC. When the national grid was installed in the early 1930s, this was AC voltage at around 415 volts 3-phase, 240 volts single phase. Faced with the choice of either replacing all the machinery or to change the AC to DC, that was the simplest option, and the technology of the day was the mercury arc rectifier. Rectifiers work because they will only pass current in one direction. AC reverses current and continually, in our case in the UK 50 times a second. If you apply an AC voltage to a rectifier, it will cut out the reversed half of the cycle. So you get current that flows only in one direction, that is a form of DC. Mercury arc rectifiers were invented by a man called Peter Cooper Hewitt. He was the inventor of the mercury discharge lamp. He was trying to produce a light that was brighter than the currently available incandescent lamps, and he patented that in 1901, but realized that if you put AC across a mercury vapor lamp, it rectified into a form of DC. And from that, he developed the mercury arc rectifier. These contain a pool of mercury in the bottom of the bowl, which produces a vapor which fills the bowl. Around the periphery are the electrodes, the anodes, which collect the current. These rectifiers were made at the Hackbridge and Hewittic Company, which was actually based in Walton-on-Thames, just a few miles from where we are in this building today. Now, to start a rectifier, you need an arc, and as it's a totally enclosed glass envelope, what you have is a spring wire from a small arm which is just out of sight, which has an electromagnet under it. When we start the rectifier, the electromagnet pulls the wire into the mercury pool. That shorts the electromagnet out, which releases the wire and creates a spark, which is then picked up by two small anodes at the back to keep the arc flowing. What happens is when the spark is created, it ionizes the mercury vapor and makes it conductive. When we apply 6 phases around the main anodes and connect to load, the arc is picked up by each of the anodes, and whichever of the anodes is positive at that one time, that's the anode that conducts. So in fact the arc is passed around between the anodes successively, round and around and around. Of course this happens at a very rapid rate, and so you can't actually see it rotating, but what you will see is where the arc touches the mercury at the bottom creates a very bright spark, and because the arc is moving around, this spark darts about. We have a transformer in the basement which converts the incoming 3-phase supplies to 6 phases, but because it's rather large, you can't just connect it straight to the supply. So there's a starting sequence. This takes about 5 seconds. So when I press the start button, there will be a gap of about 5 seconds. The arc will be struck and picked up, and you will see it operating. At the same time, the cooling fans at the bottom of the cabinet will also start. So I'll now move over to the end of the cabinet and press the start button. And the starting sequence is going through, and immediately the rectifiers start. Now you'll see that because the electricity is flowing through the mercury vapor glows this characteristic blue-green color. The more current we pull through the arc, the brighter it becomes, and we can demonstrate that in just a moment. But to do so, I need to connect the rectifiers. These two rectifiers work in parallel to the main DC switchboard, and we do this with the switch at the top here. That's now connected these rectifiers to that switchboard, and you can see we're generating a voltage there. I shall now switch the mercury arc rectifiers onto the main distribution bus bars. There, we're now connected to the bus bars and can connect any of the loads around the building using the individual switches here. Okay, I'm now going to switch on some power which will use the rectifiers, and you'll see that as I switch it on, the glow in the bulb will become brighter. Firstly, I'll connect a load which is 20 amps. You'll see the meter at the top read. 20 amps is fairly near the bottom of the meter, so it won't move it a great deal. So that the glow has got much brighter, and all of the anodes are now in operation. If I switch that off and connect a load which is 40 amps, you'll see that gets brighter again, and the meter is now reading 40 amps, and with the two together, that's as bright as we will go today.